Explain why you would not expect titanium chloride to be a liquid at room temperature. Explain why you would not expect. Okay, so looking at this, titanium chloride, you would expect titanium chloride to be an ionic compound. Why? Because it's got a metal and a non-metal. So you would expect TiCl4 to be an ionic compound. That's straight away 1 mark. You would expect it to be an ionic compound. Now, what do we expect ionic compounds to do? Well, we expect ionic compounds to have high melting points. So we can say ionic compounds have high melting points, and then we can give a reason why. Okay, or you can put in brackets are solid at room temperature. But now we need to give a reason why. So because, ever important word in science, because the forces of I'm going to actually use the word electrostatic forces. The electrostatic forces of attraction are strong. And that's the really important. The forces of attraction, or electrostatic forces of attraction, between the ions are strong. You could even actually improve that, I'd say, by putting between the ions. Okay. Gonna add that. Between the ions are strong. The between the ions actually is very important. You'd need the between the ions to get the mark there. So sodium ions are oxidized to sodium ions. So sodium atoms are oxidized to sodium ions in reaction. What is an oxidization reaction? Straight away we write oil rig. Oxidation is loss, reduction is gain. So really, really useful acronym. So we know that sodium ions are oxidized. So we need to say sodium, and we have to be specific to say sodium. Sodium atoms, they're being oxidized. So oxidization, okay, is loss. So sodium atoms are losing an electron. You could actually just say losing electrons is fine, but we know that Na plus goes to, Na goes to Na plus by losing 1 electron. Complete the half equation. Well, that's actually just what I've said, that Na goes to Na plus plus an electron. You have to write E minus. If you just write down E, that's not correct. You have to write down an equation. You can't write down in words. It has to be Na plus and E minus. Question 6.7, the big maths question. Now, this is a very important question for how we lay it out. So we're going to lay it out very carefully. Explain why titanium chloride is the limiting reactant. So when we're looking for a limiting reactant, we're looking for the one that does not have enough moles to react. So straight away looking at this, we know that 1 mole, because there's a 1 here, remember, which is invisible 1 mole of titanium chloride plus 4 moles of sodium goes to 1 mole of titanium and 4 moles of sodium chloride. So we need 1 mole of titanium chloride for every 4 moles of sodium. We're giving 40 kilograms. Now, straight away, we have got a warning flag here. This is in kilograms. This is not physics. This is chemistry. We do not work in kilograms in chemistry. We work in grams. Straight away, you could lose 2 marks for not doing the conversions. So we're going to lay this out in a very, very specific way. We're going to write down here TiCl4 plus 4Na. We don't need to worry about the rest because we're looking at reactants, we're not looking at products. We need to start with the MR. And when you look across here, and we need to calculate the MR, so straight away we've got 48 plus 4 times 35.5. And then we've got 4 times 23. It's important to put these workings down. It's important to make sure you are writing the workings. So we're going to have 4 times 35.5. That gives us 142. Add 48 gives us 190. And 4 times 23 is going to give us 92. So now we need to work out the number of moles. And moles is going to be equal to, we can write this anywhere we want. I'm going to write it up here. So moles equals mass over MR. So moles is going to equal mass, and we're told the mass here, titanium chloride, is 40,000 grams. You can put the grams in if you want. Divided by the MR, 190 equals. So let's do that. 40,000 divided by 190 equals 210.526. Could give myself a little bit more space here on this side. So now I'm going to have sodium. Sodium has got 20,000 grams divided by 92, which is going to equal 217.391 grams, moles. So for all of the titanium to be reacted, it would need to have 4 times that number of moles of sodium. So far actually we've got 3 of the 4 marks. We've got 1 mark for working out this. We've got 1 mark for working out this and 1 mark for working out this. So if you have not calculated the masses in grams, you've already lost 2 marks here. So now we actually need to put an explanation. So the way I'm going to explain it is this. I'm going to say for 210.5, I'm just going to round there, moles of titanium chloride to react completely, it would need how much? It would need 4 times that because it's a 4-to-1 ratio. So it would need 4 times 210. It would need, so 4 times 210.5. It would need 842 moles of sodium. So sodium is the limiting reactant. And that's our 4th mark, the explanation mark. Okay, there are other ways to explain it. You could just say that the titanium is not in excess because there are less moles than required to fully react, but this way explains it very clearly and uses the moles that you've calculated in your explanation. Much easier question. Lots of people got this even if they didn't get the previous question. Actually, just going back to the previous question, if you hadn't used grams, then the only marks you could have got were the first marking point for 190 and the last marking point. So lots of people were getting 2 out of 4, but they were out by a factor of 1,000 on the number of moles produced because they did not convert to grams. So yield is just mass divided by theoretical mass. So let's just write that down. Yield is mass over theoretical critical mass. And so we've got our mass here. The maximum theoretical mass of the batch was 13.5 and the yield is 97. So we need to rearrange that. So we have, if I write it out fully, we have 92.3%. I substitute equals mass divided by theoretical mass 13.5. Now I can rearrange and do 13.5 times by 92.3. And we get 13.5 times 92.3. We get 1,246.05 kilograms. Okay, but we actually don't get that because we haven't divided by 100. Okay, so that should be mass times 100. So we need to actually also divide this by 100. So that's going to be 12.46. You could also get the mark there for saying 12.5, but it doesn't say that you should be rounding it. One of those rare cases where it doesn't actually state whether you should round something or not. So 12.4 or 12.46, sorry, 12.5 or 12.46 or 12.461 was allowed. Note that you can't have 12.4. Why can't you have 12.4? Because 12.4 is not 12.46 rounded. You've just forgotten to put the 6. So anybody that wrote 12.4 would only get 1 mark for showing they're working. So we know that times 100, that should be the correct working there. Okay,